Hey guys, this is MathCamp321. In today's lesson, we're going to be talking about some basic differentiation rules. In our last unit, we learned how to find the derivatives using a limit process, and oftentimes this was lengthy and time-consuming. In today's lesson, I'm going to give you a shortcut for finding the derivative of certain types of functions. The first rule that we're going to look at is known as the constant rule. And what it says right here is that the derivative of a constant function is 0. That is, if c is some real number, then its derivative is 0. Let's go take a look at these specific cases. Consider the horizontal line y equals 4. What is the slope of the tangent line at x equals 2? Well, if I find x equals 2 and I look at that point right there, if I wanted to draw the tangent line, or the line that skims the surface of this horizontal line, that tangent line would have a slope of 0, thus confirming the rule, the derivative of any constant function is 0. Let's take a look at the second part. What would be the slope of the tangent line at x equals -3? So what I'm going to do here is we'll find x equals -3. That's over here. And if I were to skim the surface with a tangent line there, that too would have a slope of 0. So based off of these two examples, we can say that the derivative of any constant function is 0. Here are a couple very easy cases, or I should say, here are a couple of very easy examples. For each function below, give the derivative using notation that is consistent with the given function. So for number 1, it says y equals -5. Well, that's a constant function, so therefore its derivative will be 0, and I'm going to notate it in the following way. Y prime is equal to 0. So I'm using notation that's consistent with the originally stated problem. Number 2, the function is f of x equals 0. Well, this is another constant function, and its derivative is also going to be 0. So we'll notate this as f prime of x is equal to 0. In our third case, we're given the function s of t equals 10. Well, 10 is a constant function, so its derivative is going to be 0. This will be notated as s prime of t is equal to 0. Number 4, y equals k pi squared, where k is some constant. The interesting thing about this one is k is a constant and pi is also a constant, 3.14. And if you square it, it's still going to be a constant. So we have just a product of constants here, which is still just a constant. And if we're dealing with the constant function, we know that its derivative is 0. So that would be notated as y prime is equal to 0. So that is the constant rule. We could put a check by that. I think we just got that taken care of. Now let's look at the line rule. The derivative of a linear function y equals mx plus b is equal to m. That is, if m and b are real numbers, then the derivative of the expression mx plus b is just going to be m, or whatever the slope happens to be. So let me convince you of that by looking at this specific example. So consider the line y equals 1/2 x minus 1. Here is that line drawn for us down below. What is the slope of the tangent line at x equals 0? So we'll find x equals 0, we'll put a point there, and we'll draw a line that skims the surface. Well, that tangent line has the same slope as the line itself. So this guy is going to have a slope of 1/2, which isn't surprising because the rule says the slope of a line is just going to be the slope itself. So not a surprise there. If we look at the second example, what is the slope of the tangent line at x equals 4? Well, here's the point at x equals 4. The tangent line will skim the surface. And again, it's going to have the same steepness as the function itself. So the slope there is also going to be the same as the original line, 1/2. So once again, if we're dealing with the derivative of a sloped line, then the derivative will just be the slope itself. So let's practice that idea with the next 4 questions. So question number 5, y equals -12x minus 3. This is a sloped function with a slope of -12. So the derivative will be -12. And that'll be notated as y prime equals -12. Here, the linear function's written backwards, but that's not a big deal. If you feel comfortable, you could just go right to the answer. But if you want to change the order, that's okay too. Now it looks a lot more like y equals mx plus b. The slope here is 4/5, so the derivative will be 4/5. The derivative is the same as the slope. In number 7, the linear function's a little bit more disguised. So I'm going to engage in a process known as Moo. Moo is an acronym for many over 1. I've got several things over 1, just 2 things really. And the Moo rule looks like this. If I have A plus B over C, this is the same as A over C plus B over C. So that was a little digression of the Moo rule. I'm going to apply it to the function v of t right now. So v of t is equal to 1/7 take away t over 7. Again, this is a little bit disguised, so maybe you would prefer to write this in a slightly different way like this. V of t is equal to -1/7 t plus 1/7. So I took this element in back and wrote it in front, and I took this element in front and wrote it in the back. Now it looks like y equals mx plus b, and the derivative is just going to be the slope. So the slope is going to be -1/7. And for the final question, we have a bit of a throwback to the top of the page. This is just a constant function. And we said at the top of the page that if you're taking the derivative of a constant function, then the derivative is just going to be 0. So on this page, we discussed 2 shortcuts for taking a derivative that have nothing to do with the limit process. They're just shorter ways of getting to that derivative.